Hello, welcome back. Hope you are enjoying my lectures. We started off almost around 10 lectures ago, the Newton's laws of motion or the dynamics. We went on to look at each of the forces separately. First, we discussed in great detail about the tension. Then we started the normal force or the pressing force. This is also treated as one of the components of the total contact force. This is how we have seen. And we were discussing the inclined surfaces. I think I gave you about three ways how to get the constraints of that, etc. Okay. Now, for example, look at this. You have an inclined surface. Supposing I am applying a force F on this, let us say. Its mass is m, its mass is small m. Let it accelerate with the b. Let it accelerate with b. Let us try to discuss this scenario. How, you see, if you do it with very little force, that body would accelerate down. But if you really apply with a heavy force like this, the body has a tendency to go up. Now, in between these two, you have a case where the body may remain stationary with respect to the inclined surface. So we may discuss these scenarios and what would be the normal force in such a case, etc. Let us see. First of all, I take this. This is a normal force. This is, I am avoiding writing all that, mg cos theta, mg sin theta, and if it is accelerating with v, the pseudo force will be mv. I am now making use of this pseudo force. Without that also you can do it. Now let me say this is accelerating down the incline with AR. This mv you can clearly visualize two components. This will be, if this is, sorry, again I am putting, this is beta, mv cos beta, this is mv sin beta. I told you never get confused with pseudo force technique. It is only a technique, nothing else. No such force exists. It is just for the sake of convenience we do, nothing more. Suppose it goes with respect to this means this is stationary with respect to the incline. Therefore, there is no movement. So, n is equal to mb sin beta plus mg cos beta. Okay? In this direction. Minus mb cos beta is equal to MAR. Two equations from this. You can also get FBD of this. I am applying a force here. This is N. Therefore, this component is N sin beta. This is, we have been writing this, so I am skipping explanation each and every time. And this is going with the B in that direction. So how do you write that equation? F minus n sin beta is equal to mass of this into acceleration of this. If you wish, you can do this also and write that equation as n dash is equal to mg plus n cos beta. So many ways of writing this. We will look at, I took AR down the incline and I am getting this expression. Look at how many variables are there. N, B, AR. Because F is known. 3 variables, 3 equations. You can definitely solve this problem. Okay. From these two, we will eliminate n first. How to eliminate n between these two? We have minus n means all this. mb sin beta into sin beta, sin square beta, mg cos beta sin beta is equal to tan. So instead of n, I substituted it here, multiplied the sin beta, you got it. Therefore, f minus mg cos beta sin beta equal to b into m plus rb is equal to f minus mg cos beta sin beta divided by m plus. Okay? You got it. Now if you substitute in this, you will get n because beta b is what you have to substitute from here. Okay? Now, once I get b, I can substitute in this also. You see, what are you getting here? M gets cancelled everywhere. Okay? I am erasing this part. And then G R is equal to G sin beta minus all this into cos beta. mg cos beta sin beta into cos beta divided by m plus m sin square beta likewise. So if you substitute it here, you will get mg sin beta. So this term is over. Now this term will be mg sin cube beta minus f cos beta plus mg cos square beta sin beta by m plus m. All this you can easily do it. That is the value of b. We substituted, we are getting this. Now between these two mg sin beta is common. Then what are you getting? Cos square plus sin square is 1. So what are you getting there? You are getting mg sin beta plus small mg sin beta. That is mg sin beta plus small mg sin beta minus f cos beta divided by m plus m sin square beta. This is your AR. Hope you have got this point. And similarly, you can find out what is your n in this case. Uh, I would be writing the expression for b here, f minus mg cos beta sin beta whole divided by. So we got that expression. So I can erase even this part and write this there. Okay. Now what is left for us? Let us write this also. Here originally g sin beta minus this also I can erase. Now I want to get n. How do I do that? N is equal to, n of course is common, b sin beta. The whole thing is to be multiplied with the sin beta. F minus mg sin beta cos beta m plus m sin square beta into sin beta plus mg mg sin beta mg cos beta. If I multiply and divide with this, it is as though I have taken LCM. I'll write your n expression here, mb sin beta plus mg cos beta. Okay? Right. Now it's a mere simplification. M by m plus m sin square beta. Now you get f sin beta minus mg sin square beta cos beta. This is over plus this is this m must be inside. So I can write here m and m square because the m we have introduced inside. So what do you get here? M square g cos beta sin square beta plus mmg cos beta. Bluntly go on doing it. Right. Now I think you can clearly see sin square beta, cos square beta. This is getting cancelled. What are you getting? This m I can't do it here. If I take common now, because when I wrote inside here, I need not write outside. Sin square beta, you have f sin beta m we have taken common. This is your n. A very complicated expression indeed, no doubt about that. But that's how the value is. Right? Now, n if you see right from the beginning, fixed incline we got mg cos theta, moving incline we are getting different values. Now another different value we got here, this is when it accelerates down the incline. Down the incline means what? AR down the incline means AR must be greater than 0. G sin beta or B must be less than G tan beta. Or what? AR down the incline. I want AR to be up the incline, then what should happen? Obviously, as simple as that. But then there is a special case. If there is B equal to G tan beta, then AR is equal to 0. Neither goes down the incline nor goes up the incline. Right? So, what does it convey? This is a condition where that the body remains stationary relative to the inclined surface. They ask this question almost frequently in every exam. Be careful about this condition. In this condition, what will be the normal force? You already have it here. What is normal force in such a scenario? Equal to mb sin beta. B is G tan beta, that is cos beta. Now that sin beta I am writing, and then G cos beta. I multiply and divide with cos beta so that denominator is same. What are you getting? Mg sin square plus mg cos square. Now this is a very, very important result. Fixed incline when you got mg cos beta. Moving incline, in this case, if it is stationary, you are getting mg by cos beta. You get the point. So, and if it is down the incline, we have shown what Ian have derived a little while ago, that you can write down. Similarly, up the incline, you can write. Okay? Now, so, N is equal to mg by cos beta. N is equal to mg by cos beta. What is the condition you are getting? R is equal to 0 and B is equal to G tan beta in the scenario. Sometimes they will ask you, look here, when they give say body, instead of force, maybe they may give this is M. What is M dash for M to be at rest with respect to capital M? Same as what I have discussed. I applied a force, now I have attached it that so that it is pulling down with certain force. So they may ask, so everything is same, but let it accelerate with B. Therefore, this also will go down with B. Alright? Then, what do you get here? B is equal to, let this angle be beta. G tan beta. I did not have to get that again. I got it. But here, this is M dash D. This is a T. Okay? And here also it is T. So what you should write here is additional equations. What are the additional equations? I am erasing this part. What are the additional equations? M dash D minus T is equal to M dash. For this, what do you write? For this one, can you? T, B. The previous case we wrote F, now you write T, that's all the difference. Therefore, T minus n sine beta is equal to mb. But n we just got it. N is how much? mg by cos beta for this to be stationary relative to that inclined surface. Okay? Yeah. Now you got it. B you can substitute, N you can substitute. If you add these two, T gets cancelled. M dash G minus what is N? mg by cos beta sin beta m plus m dash b. Okay? Right. Now I think I can erase this part. Now you want to know m dash. So m dash you bring everything on to one side. M dash g minus one thing I can do here. B is g tan beta. So I can eliminate g from all this. There is cos beta, there is cos beta. So this also I can get cancelled. And then that's it you have. Bring everything onto one side. M dash cos beta minus sin beta is equal to m sin beta plus small m sin beta. So m dash is equal to m plus m sin beta by cos beta. You can write this in several ways. You divide with sin beta so that you get m plus n by. So whichever way you want, you can do it. I've just given you an example how this could be applied. Okay? Now, they may ask acceleration. Directly you find out and solve it. There is no problem with that. Okay? Now, so what we saw, we have applied a force in the forward direction. What if I suppose this is smooth surfaces. I am pulling it in a backward direction. Okay? Now, what is that minimum B such that this body will fall vertically down? What do you mean by that? It should just lose contact. For example, in such a scenario, exactly it will fall like this. It is falling like this only, whereas although they appear to be in contact, that contact is infinitesimally, of course, in a very small interval it is lost. So it virtually falls vertically down. That means n must be 0. Okay? So what we shall do first, this is n, this is B means this is mb pseudo force, mg cos beta, mg sin beta, you can mb cos beta, mb sin beta. So whatever way it is. Now look at this. N plus mb sin beta is equal to mg cos beta. I want my n to be 0. Now this is where physics problem comes. You should always be careful about the logic. He says it should fall vertically down. That means these two should not have a contact. If I suddenly do it, it will anyway fall. But I want only the minimum value. So n is just 0. I am putting n 0. If n is 0, what am I getting? B is equal to g cot beta, then the body will fall with g vertically down. I hope this is clear to you. So if you put it in the forward, try to pull it in the forward direction, there are certain scenarios. Put it in the backward direction, you have certain scenarios that you saw. And I have taken this in the vertically up and down directions. I have virtually shown you in almost all these cases where you come across this normal force, okay? Inclined surfaces we saw. Now, supposing somewhere let this be beta. There is a pulley fixed to the wedge. As it moves down, this will move back. Along with the pulley, this inclined surface also moves back. As it falls, we were taking before, let B be the acceleration like this. Okay? Now first what we have to see. Wedge constraint you have to do. Then pulley constraint. This is combined wedge and pulley constraint. Combined pulley and wedge constraint. Let this be x-axis as we were taking before. Now this is going with me, this is also going with me. Let me say this is going with AX like this. Perpendicular to that AY it is going like this. Now use your two-finger technique. At this point fix it. What are you getting? Plus AX. Follow my arguments carefully. Now here in the direction of the segment, this is going with B. But in this line, if this is beta, it is B cos beta in that direction. Whenever you use that two-finger technique, you have to see in the direction of the string or segment. This is the segment. So I am taking it here, B cos beta. Now I take again plus AX. And this is plus B cos beta. I hope that is clear to you. Okay? And then come to this segment. This is fixed, whereas this is decreasing. So, minus B. 1, 2 segments, 2 and 1 value. So, the whole thing is 0. Therefore, this is the constraint relation. Got this? Then, if this is constraint of pulley, what is wedge constraint here? What is wedge constraint? We already did it. I want you to do it as many times as possible. You have fixed your x. You have fixed your y-axis. Initially it is here. maybe it is somewhere there. Okay? So, this is AY, this is B, this is beta. I told you to construct that right angle triangle there. Now sin beta is equal to AY by B. This is AY is equal to B sin beta is wedge constraint, and AX is equal to B into 1 minus cos beta is pulley constraint. How to write the equations here? I'll show you that. You have to be very careful while drawing FBD. I'll show it here to you. T, okay? This is mg sin beta n mg cos beta. That's it, mg n t. Okay? How do you write it? You say this is going down like this. So, mg sin beta minus t is equal to max, and ay is like this. Ay is like that. You see? In that case, I'll write mg cos beta minus n is equal to may. Right? Now the interesting aspect comes here. Look, that pulley is fixed to the wedge. What are all the forces acting on the wedge? Okay? Now, look, what is this? The string, one is pulling it like this, another is pulling it like this. This is very crucial. Likewise, it is pulling, horizontally it is pulling. Both I have to draw. Both I have to draw here. And then, this is going to be. So, n sin beta, n cos beta. Here, if this tension I take the component, what is this 90? D cos 90 minus beta. And here it is T cos beta. I show it to you. T cos beta, T sin beta, all this thing. Okay? Now look at horizontal direction. N sin beta minus opposing is what? T cos beta is equal to capital M into B. Okay? Now n dash, how do you write? N dash is equal to mg plus T sin beta plus n cos. This is how you have to write the equations. And then two constraints. Look how many variables are there. Ax, ay, b, t, n, 5 variables. 1, 2, 3, 4, 5 equation. If you want to solve this as additional equation, additional variable. So one by one you can do that and try to solve this on your own. It may take little time, but it will be interesting for you to do that. Okay? Okay. Now you see.